Okay, so basically, we will do integration by parts. In our first class, I have discussed about the formula. That was just like this. That is integration uh, u v dx equals to u integration v dx, the negative integration d dx of u, that integration v dx, and whole integral dx. Yeah, that is uh, this I have discussed on this formula. Okay, uh, this one here, this formula here, this one, and also this one. Three formulas that all of them are same. If we follow your textbook, that is from Oxford, they follow this formula, this presentation, right? This expression basically. Yeah. And if you go through the integration by parts, then you will find this one. Basically, this one and this one, both of them are same. Okay. Yeah. Okay. So even you can follow this one, even you can follow this one, also you can follow this one. So I think third one, that is this one, is looks like more simple than the others, right? Okay, okay. And also I have discussed about a word that is LIATE. Can you remember that? Okay, that is L. L is for what type of function? Indicate L. Mm, logs and ln, right? Natural log, right? That is ln. And I is for inverse function. That is R trigonometric function. Inverse trigonometric function. These are just like you can write cos inverse x, or even you can write it as arc cosine, right? Okay. A is algebraic, that is included with 1 x, or even x squared, or even 2x plus 1, just like this. Okay, this type of function. Okay, and t is for trigonometric function, that is included in, right, included with the sine, that is sine x or cosine x or tangent x and cotangent, uh, just like that. And is for exponential function, that is e power x or e to the power mx, where m is a number. Okay, is it clear to you? Okay, okay. Now if we now try to solve problems based on this, then we will have, at first if I show you a problem solving the formula, then okay, if I discuss about with integral, that is x and e x dx. Okay, now here we will follow this one. Okay, okay. Now if we try to apply this formula, then we have to identify here we have two terms. One is u, which is dv, u and v, u and dv, right? Okay, so we have here, mm, if we go through this function, then we have here x, and another one is ex dx. So if we remember the word, if we remember the word liate, so a is before the e, right? Okay, okay. So we will consider this one u and this one dv. Okay, okay. Now we have to find four terms to apply this formula. That is, first one is u. If we look at the formula, if we look at the formula, then we have here, we need to find u. That is, already we have decided which one will be u. Okay, and then we have to find v. We have to find v. Okay, and then we have to find du, right? Okay, then u, we have to find four terms. That is u, then du, okay, then v, and then dv. Now how can you find this? So u, okay, u is x, so du is 1 times dx, right? Okay, and then dv is ex and dx, right? We have here dv. Sorry. Okay, okay, okay. If we go for first one, that is, then we have to put negative sign here, then it will be negative here. Okay, okay, thank you. Now, so how can we find this v? How can we? Yeah, yeah. Okay, we integrate dv so that we will get v, right? Yeah, yeah. So it would be negative negative x, right? Okay, okay, okay. Now we if we put the values in the formula, then we'll get the result. The formula is the formula is the formula is u dv, that is u times v minus integral v du. Okay, so okay, so therefore, uh, integral x e power negative x dx, that is equals to u. What is u here? X. And what is v? Negative e power negative x. Okay, okay, and then okay, then minus, okay, then minus, okay, integral v. What is v? That is negative e e negative x, and then du, that is dx. 1, so it will be dx. Okay. Yeah. Now we have to simplify this. Then we will have negative x e negative x and then plus ex negative. So what will be the integral? Ex negative ex, right? Negative e negative x, negative e negative x. Okay, and then plus c. We have to put plus c. Okay, okay. So wait, so now we will have, if we simplify this term, negative e negative x, then x plus 1 plus c. Okay, okay. Now, uh, sorry. Yeah, okay. Yeah, okay. Now, note it down. Okay. Is it done? Okay, okay, okay. Now I think you can do number B. Okay, try this one. Which one is U? X is U. And that is dV. That is dV. Okay. Yeah. Okay. dV. Sine X. Right. Okay. Is sine X. Sine X. And here du. Okay. That is dx. 1 dx. That is dx only. Okay. Now x sine X. That is x sine X. Then minus integral. That is sine X. Sine X dx. So the next line will be x sine x, and then plus cosine, and then plus c. Okay, good, good, good. Okay, now go for next one. Here we have, I think you can already solve this one. We have now solved x cosine x, so you can solve it, right? Okay, and then now, okay, okay. Now go for number C. Okay, x square ln x, right? So which one will be u here? Which one? The word is Liate, right? What will be the u? U. That is u, right? Yeah. X square dx. X square dx. Okay. X square dx. So u equals dv is x square dx. Okay. Okay. So du is 1 over x dx. Okay. And then v x cube over 3. Okay. Good. Okay. Now complete. Sorry. So is it done? X cube over 9. Right, right, right. So that is uh, ln x times x cube over 3, then minus v, that is x cubed by 3 over 3. Okay, then du, that is 1 over x dx. That means 1 over 3 x cubed ln x, then minus 1 over 3 integral x squared dx. So 1 over 3 x cubed ln x, then minus 1 over 9 x cubed plus c, right? Okay. uh, Go for year number A. So since here we are, if we notice the term integral here, that is we are given only ln x dx. So hence we have to write ln x as 1 times ln x. Then we will have two terms. Okay. Hmm. Now, so ln x, so ln x times 1 dx, right? So which one is u here? U is ln x and dv. Okay, now complete it. U prime, yeah. U equals to x. Okay, complete it. Okay, okay. Write down on your copy. Okay, on your paper. On your paper. Okay. Okay. Integral of uh, one. No, no, no. What is the value of v here? Okay, 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 okay. That you're right. Okay. Okay, I'm writing it. I'm writing it. You don't need to write. Okay. Okay, okay, okay. So it will be over 1 over x and then dx, right? And then the integral will be here uv, that is l and x times x, and then negative that is x, and then 1 time 1 over x dx. So x and x will be cancelled out. That will be 1. So it will be x ln x minus x plus c. Okay, okay. And you can take x common. Okay, yeah. If we rewrite this, then it will be x ln x minus 1 and then plus c. Okay. Hence, number B, I think you can also do it by yourself, dx. So here also you have to rewrite the integral as ln x square times 1 dx, right? Okay. So this will be your homework, okay? Home task. Okay. Okay. And then if we go for next one, I think it's already done by us. Okay. Now here, number A is integration by first to find. Try number A. I think here you will need to use substitution also. Try number A. Number A. X square ln x cube and then dx. So at first identify which one is u, which one is dv. Okay, which one is u? That is u, right? And then this one, including dx, that is dv. Okay, so u equals to ln x cube, and then you have to find du, and then dv equals to x square dx, and then you have to find v. Okay, do it on your paper. Okay, on my book. Okay. What is the result of du? Now here you have to use chain rule. Yeah, derivative. So that is 1 over x cube. Then you have to again differentiate x cube, right? That will be 2x square and then dx. 2 over x, right? And then what is the value of v? Okay, x cube over 3. Right, so here you can rewrite this 2 over x dx. Okay, now substitute this in the formula. if we substitute this, then we what will we get here? Ln x cube multiplied by x cube over 3, then negative v, that is x cube over 3 and then 2 over x dx. Okay, then we'll, okay, 1 over 3 x cube ln x cube, then we will have here negative 2 over 3 outside the integral. Okay, then x square dx. Okay, so 1 over 3 x cube and then ln x cube and then negative, here we will have 2 over 3 and then here x cube over 3, right? So it will be 9 x cube plus c. Okay, okay, okay. Now write it on your book. Okay, done. Okay, then go for number B. Yeah, which one will be E here? Okay, sine x as U and then e to x and dx. Okay, yeah, that will be dv. Okay, okay, u is sine x, so du is cosine x, and then v is, we have to find out v, then dv equals to e to x dx. So what will be v here? Okay, 1 of 2 e to x, right? Okay, now we put this values in the formula. Yeah, we have to substitute in the formula. Okay, then sine x 1 over e power 2x, then minus integral 1 over 2 e to x, and then, okay, here, so here cosine x dx. Okay, now if we go for this one, again we have a similar type of integral. here, right? That means we have to again apply integration by parts. Okay, that means this is the repeated integration by parts. You have to apply integration by parts twice. Repeated, right? Repeated. So in this case, we have to let the given integral as I. So value of I is this, right? Okay, then we have here I only. Okay, and then you have to find the integral of this, again applying integration by parts. So we have to again apply here, that is integral e. If we take 1 over 2 outside, okay, then we have only e power 2x, then cosine x dx. Okay, now here we have to choose cosine x as u, right? So again, u is cosine x. So du will be here negative sine x dx. And v we have to find out, and dv equals to here e power 2x dx. So v will be here 1 over 2 e power 2x. Okay. Now, again, if we substitute these values here, then we will have e power 2x cos x dx equals to uv, that is 1 over 2 e 2x, then cosine x, and the negative integral, that is v. Okay, v is half 1 over 2 e to the power 2x, and then du, that is negative sine x dx. Yeah, so from here we will get 1 over 2 e power 2x cosine x, and then it will be plus, and here 1 over 2 integral e to power 2x sine x dx, right? That means if we notice the term here, from here we have started, right? That, yeah, that is the term we started. Okay, so we have let it as I, right? If we substitute I here, then we will have here that is how 1 over 2 e to the power 2x cos cosine x plus 1 over 2I, that is the integral. Now if we substitute the values of this in place of this, that is, that will be here, we have to substitute here. Okay, except half. Is it okay? Now uh, okay, so we, sorry, we are here. Okay, so that means we have to we have to just put the value of this into this. That means here in this line. So from here we will get I equals to 1 over 2 e power 2x sine x, and then minus half times we have this, right? Okay, so if we put the values here, 1 over 2 e power 2x, and then cosine x, and then plus 1 over 2i. Okay, now since we have here let that the value of this integral is I, right? Oh, so from here we have to find the value of I. Now if we simplify this, then we will have 1 over 2 e power 2x sine x. Then if we multiply with 1 over 2, then we will have negative 1 over 4 e power 2x cosine x, and then negative 1 over 4 I. Here, yeah, yeah. So now just take this term into left, then we will have I plus 1 over 4 I equals to from here we will have 2ex sine x minus 1 over 4 e power 2x cosine x. So the value of this here we will have 5 by 4, 5 over 4i, right? Okay. Then we have this one. We have to put this one here. Then I, value of I equals to, if we take 5 over 4 into the right, then we will have 4 over 5, right? 4 over 5 times, yeah, then we will have, we are getting 1 over 2 e power 2x, then sine x, then minus 1 over 4 e power 2x cosine x. And then you can also simplify this, then it will be, if we take 1 over 4 common, then it will be 2 here, right? So then it will be here 4 over 5 times 1 over 4, and also we can take common e power 2x, then it will be 2 sine x minus cosine x. Are you okay with this? Then we can cancel out 4, then it will be only 1 over 5 e to power 2x, then 2 sine x minus cosine x plus c. That will be that is the integral. Now 1 over 4, okay, 5 plus 5. Yeah, we take 1, yeah, Okay. Yeah. So that will be the final result will be 1 over 5 e power 2x, then 2 times sine x minus cosine x, then plus c. That is the value of the given integral. Okay. That is the repeated integration by parts. The calculation is uh, too much long. And this is the question of paper 3. Yeah, paper 3, and also in paper 2 part B. Okay, have you copied it? Okay, complete it. Okay, okay, okay. You can take your time, no problem. Okay, sure, sure, sure. Okay, now go for next. Here, this one also this type of question, that is repeated integration by parts. Okay, this one also repeated integration by parts. So try these two. Okay, at home, and then if we I, yeah, yeah. Okay, okay, right. Okay, okay. You are following Oxford book, right? Okay, then these are from your, yeah, from your textbook. So I think now you can solve this. Does it look like familiar to you now? Okay, okay, okay. We did it. That is on arc sine x, number 10. You will try this one. Okay. And, yeah, sine inverse x. We can rewrite this one as also integration sine inverse x dx. Okay, that is number 10. You can rewrite this as like this one. Okay, okay. And also here arc 4x tan inverse x, number 14. and then that is from exercise 7K. Look at this. Have, have you done integral, definite integral? Have you completed? That means you are given two limits, upper limit and lower limit, if you are given. So since here, okay, that is called definite integral, if you are given the limits. So now we are given here, but basically the integral is from integration by parts topics. But since we are given here that the lower limit and upper limit, so we can, if it is in paper 2, then we can directly use calculator. Then it will give you the direct result. Direct result if we use calculator here. Okay, but for indefinite. Yeah, GDC. Which one you use? TI-84. Oh, okay. Or TI Inspire. I think this one is more easier. Yeah, cause CE. Okay, okay. This one is more easier, I think, to operate. Okay. So in integral, you can use technology here. That means you can use ZDC here to find the value of this definite integral. If you just put the functions here, and then you will directly get the result. But if you are given it in paper 1, then you have to you can't use GDC, but you have to then find the value manually. That means you have to find at first the integral, then you have to replace or substitute the limits here, then you will get the result. Okay. Okay. So in our next class, okay, okay, okay. That is TI-84. Okay. So this calculator basically this calculator use basically library function. So you have to find out uh, where is integral. That is given in alphabetical order. Okay. And try this. You try to solve this problem by using your GDC. Okay. And yeah, and then in our next class, which topic do we need to discuss?